Hi guys, this is Dr. Gonzalez, and in this video I'm going to explain non-experimental research. This is a basic introduction to some of the concepts that we are going to cover more in depth throughout this course. So you'll see a couple of these things again later on, and don't worry at this point in time if you don't know a lot about validity, for example. I'm going to highlight things in this particular video that are very core to understanding non-experimental research. There is going to be a little bit of comparison with experimental methods, but I want you to keep in mind that the goal of this particular course, 4370, is non-experimental methods and the statistics that we use with them. So the first thing we're going to cover is the concept of variables. You've probably seen this information before, but it's a great place to start because without a thorough understanding of variables, it's going to be difficult to understand the methodology that we're going to talk about. So a variable is just a characteristic or a trait or a condition, something that can have different values as we go across individuals or groups or situations. So as researchers, variables are one of the core elements that we measure and then we use in our analysis and then later on interpretation. So some examples of some variables: we could look at a student's GPA, and we'll be measuring that with numbers, right? We could look at hours of sleep. We could say you sleep 8 hours per night. We could look at levels of stress. I could give you an inventory about stress, and you could rate yourself on that and then tell me with a number how stressed you are. I could also include categories. Are you a freshman, sophomore, junior, senior, undergraduate, graduate student, etc.? Or I could look at your major or your gender. The last two categories, the thing I mentioned about like your class level and then your major or gender, those would be variables that we're measuring in categories. So if something in a research study can change or vary in a meaningful way, that's going to be considered a variable. And as a researcher and as a research student, it's very important that you understand what variables are, because any research question that you pose is ultimately going to be about the relationship or lack thereof between those variables. So another thing I would like you to do in this course is that anytime you approach some of this material through lectures, think about your research question. You're going to be asked to come up with a research question for your final paper. And that research question in its title is probably going to mention two variables, because we're looking for, in this particular course, a study that is going to find or not find a relationship between two particular variables. So like we mentioned in the other slides, variables are a foundational piece of scientific research, because if you don't have well-defined variables, there's not going to be anything for you as a researcher to measure or compare. So what are researchers trying to do with these variables? Well, first, we use variables to help us describe characteristics of individuals or groups. So if I'm talking about the number of hours that you study as one variable and your performance on a science test as another variable, I'm going to look at characteristics like the average number of hours you studied and then your average score on the outcome exam. Researchers also use variables to look at the relationships between different factors. Okay, so maybe we're looking to predict what helps you get a higher score on a test. And we look at how many hours you studied versus the kind of study method you used. Those are our two different factors. And we're looking at building a regression model on how well those two factors predict how well you're going to do on the exam. And then another thing that we use for these variables in research is to make a prediction about outcomes. And that's going to be essential in our non-experimental research. Now, there's a lot of different categories that you could break variables down into, but the most recognizable two categories are going to be, first, quantitative variables. So quantitative implies a number, and they represent a measurable quantity. So think about things like age, test scores, reaction time, or the number of hours that you study. Those are all things that I can numerically measure, so those are quantitative variables. The other one is going to be categorical, or sometimes we refer to these as qualitative variables because they describe your group membership or categories, and we usually use qualitative labels to do this. So gender is male, female, major, science, biology, psychology, kinesiology, whatever. Classification, freshman, sophomore. So a categorical variable, it determines, if you're looking at categorical versus a quantitative variable, it might determine later on what kind of statistical analysis you're going to use. For example, we're going to talk about correlation, and depending on the type of variable you're using, you might use a Pearson's correlation or a Spearman's rho. We also can break variables down into other categories, and one of the big categories that you really need to understand in both experimental and non-experimental research is the concept of your independent versus your dependent variable. So your independent variable, we're going to often shorten that to IV. It's the variable that you're using to predict or explain changes in another variable, and that other variable is the dependent variable. We might call it the outcome variable or the response variable. It's the variable that we're measuring to see if it is changed in relation to a change in your IV. So the easiest way to think about this is that your IV is the predictor and your DV is the outcome. Now, let's clarify a couple of things about IV and DV because they're different in their conceptualization depending on if it's experimental or non-experimental research. In experimental research, we have an IV that is manipulated. And because we're manipulating it, I can determine if changes in my dependent variable are being caused by the IV itself. So that requires the researcher to go in and establish levels for your IV. And because we do that, we often use random sampling or random assignment, and that allows us to complete the requirements that we need for an experimental methodology. Now, this course focuses on non-experimental research. So in non-experimental research, your IV is going to be measured in the way that it is presented. It is not manipulated. We're just going to measure it and use it as a predictor. So this class is going to focus on those IVs as predictor variables, and we're not going to set different levels of them. We were looking at earlier the type of study method that you use and your exam outcome. And that type of study measure that you're using, I'm going to explore it within its normal observable parameters. I'm not going to manipulate it. I'm not going to randomly assign people to different groups to see if there's a causative relationship there. So what you're looking at in non-experimental research is you're looking at a possible relationship, and just because a relationship exists, it does not imply that there is causation there. We're going to talk more about this later on in the course. So let's look at an example of IV and DV. So if I had the research question, is there a relationship between study time and exam performance? My IV, my independent variable, is study time. I'm going to make an assumption for the purposes of this video that the higher you study, the more hours you spend studying, I'm hoping that your measured dependent variable would be a higher exam performance. But the bottom line is I'm not assigning you to a group for study time. I'm not putting you in group 1 and saying study, you're not allowed to study at all. In group 2, you're allowed to study 1 hour. And group 3, you're allowed to study 4 hours. I'm going to just ask everyone in my experiment or in my research study, how many hours did you study, and then what is your exam grade? So I'm not assigning study time. I'm just measuring how much they did study, and then I'm comparing my exam scores to it with a statistic. We also have other variables that, as good researchers, we have to take into consideration. The first is the concept of an extraneous variable. And that is simply any variable other than my IV or my IV that could be influencing my DV. So if I'm studying study time and exam performance, some examples of extraneous variables might be how well you knew the material beforehand. Maybe it's a subject that you're really, really good at. So your performance on that exam might be really good no matter how hard you studied. Motivation might also be another extraneous variable. Maybe you're not really motivated to study, and there's not much I can do about that, and I'm just measuring it there. But maybe I'm actually really interested to know if a certain method helped or studying more than 3 hours helped. Well, motivation to study is going to interfere with that outcome. And then the third one is sleep quality. Maybe you didn't get a good night's sleep beforehand. Maybe had you had a wonderful night's sleep, you would have performed extremely well. I don't know. That's an extraneous variable. The problem with these variables is they can introduce variability into your results, and they make it harder for us to really determine if that relationship between the IV and the DV really exists, or if it's partially or completely being impacted by another variable. Confounds are another kind of variable. It's kind of a subgroup of extraneous variables. And a confounding variable influences both your IV and your DV at the same time. So what it is it's providing another explanation for whatever potential relationship you're looking at. So an example is if we find a relationship between screen time and lower grades, confounding variable in this situation might be poor time management. It might not really be that there is a relationship between screen time and lower grades. Maybe it's just the fact that you're not studying in the correct way because you're not managing your time well. So the explanation underneath here says students who manage their time poorly may both use more screen time and perform worse academically. So confounds are a huge issue with non-experimental research because they prevent us from making a clear, definitive causal conclusion. And remember, we're not out there trying to establish causation, but because of the way non-experimental research is set up, if I don't control for those confounds, any relationship that I get, even short of a causal conclusion, could be misinterpreted. Now, control variables are variables that we as researchers are going to attempt to hold steady in order to reduce their impact as a confounding variable. So there's several different ways that I can do that as a researcher. I might hold a variable constant. I might match participants so that they have the same level of a certain variable. Or there are some statistical procedures that we can use that help us control for that variable. So an example would include something like a researcher studying sleep and GPA might control for course difficulty to make sure that that's not a factor that is influencing our results. So I'm looking at sleep, I want to look at GPA, but I'm not going to, I am going to make sure I exclude courses that are extremely difficult, because those right there being difficult is a variable that could impact both of those variables. So a control variable helps you as a researcher improve the quality of your study, but there is no situation where you can 100% eliminate all potential confounds. Now I'm going to briefly touch on something that is an operational definition. In a couple of weeks or in a couple of modules, you're going to get a thorough explanation of operational definitions, because I'm going to ask you to operationally define something that you are trying to use in your paper. So whenever we establish an operational definition, we're setting forth a particular set of criteria on how us as researchers are going to measure or define a variable in our study. So for example, stress. Maybe I'm looking at stress as a variable. Stress in and of itself is a concept, and without a clearly defined way of measuring it, I am not going to have a good research study. It's not going to be very reliable there. So I want to define my measurement of stress as a score on a standardized stress questionnaire. Another example is academic performance. I could say earning an A in a class is an example of academic performance, but an A is a categorical variable. Maybe I want to look at numerical type variables. So I'm going to establish that academic performance is going to be measured by GPA. So these definitions are extremely critical because they take these abstract concepts like sleep and stress and they turn them into things that we can measure. And they let other researchers be able to replicate our study. And that's going to be important in a few weeks when we talk about replication. So now that you understand variables, let's talk about non-experimental research. And you've already got a couple of ideas about what that might entail. But non-experimental research is a kind of research where your variables are measured as they naturally occur, without any sort of manipulation by you, the researcher. So in other words, you're not going to assign participants to certain conditions. You're not going to have condition 1 with 3 hours of study time, condition 2 with 8 hours of study time, and condition 3, no hours of study time. Those are examples of ways that you would manipulate your variable for an experimental setup, and we're not doing that. What we would do is simply ask our participants to tell us, how many hours did you study? And then maybe I get an average. The other thing is the IV is not controlled or manipulated. So you don't have those levels and you don't have random assignment going on. In other words, it's researcher looking and measuring variables in the way they naturally occur in natural settings. There are some specific characteristics that define non-experimental research. First, we just talked about this. Your IV is not manipulated. There are not different levels of studying. Okay? Participants are also not randomly assigned to groups or levels. And your variables are just going to be measured rather than controlled. So hopefully you're beginning to see that there is a downside to this, and that downside is you as a researcher have less control over your study compared to an experiment, okay? And that's going to limit the way that you can interpret your results. So what kind of goals are we hoping to achieve through non-experimental research? First of all, non-experimental research is great for describing characteristics or behaviors. Maybe I want to describe the characteristics or the behaviors that a high-performing student has in a very difficult class. So I might describe that they're good at time management, that they devote time to their studies, that they get a full night's sleep beforehand. I've just given 3 wonderful descriptors of a person who would achieve high scores on a test in that course. And then once we've established that there's a relationship between certain variables, we can build models and actually predict what components of that formula, for lack of a better term, would imply that the student is going to do better. So experiments are looking at cause and effect relationships. Non-experimental research is not designed to do that. So when is there a clear advantage to using non-experimental research? Well, first of all, let me go back and emphasize that in psychology and in the research world in general, the gold standard is an experiment. We want to do experiments. But that doesn't mean non-experimental research has no value. And in fact, before I can do an experiment, I have to have non-experimental data that shows there is a relationship between two particular variables. That being said, there are times when non-experimental research is going to be your go-to because of certain situational variables. So, for example, when you can't manipulate a variable at all, like age or personality traits, those are examples of times where I would do non-experimental research. The second one would be manipulation that would be unethical. So, for example, I'm not going to randomly assign people into groups to receive or not receive a traumatic event. That is definitely unethical. And we're going to talk about ethics clearly as we go further in this course. The goal when we do use research in a non-experimental setting is we're looking at a real-world relationship. That it would be a definite time when we're going to use non-experimental. So if you look at the bottom there, I listed out an example. It says a researcher may study the relationship between anxiety and sleep quality. That's a great topic to study. The thing is, I can't ethically manipulate anxiety levels. I cannot intentionally place people using random assignment into high, medium, and low anxiety levels. That would not be ethical. So that brings us back to the key differences between experimental and non-experimental. In experimental research, you have obvious manipulation of that IV, and we use random assignment. Non-experimental just measures the variables without manipulation, and it does not use random assignment. And what that does is it lets us talk about relationships, but we can't determine if causality exists. And so you need to keep this in mind when you're looking at research, because it's important to know if it was experimental or not so that you can interpret the research findings correctly. So let's talk briefly about some common non-experimental research types. So there's 3 that I listed here. There are many others, but the 3 that you are most likely to come across when you're doing like your literature review for this class are correlational research, observational research, and cross-sectional research. And the thing these 3 have in common is that they're focusing on measuring a variable without manipulating the independent variable. Correlational research is the one we're going to focus on a lot in this class, and your research paper that you write is going to propose a correlational research study. In a correlation, we want to know if 2 variables are related to each other. Do they change together? Okay. We use this to identify patterns and relationships, but they don't imply causation. The follow-up to correlational research would be some form of experiment. Observational research, it's just what it implies with the word observation. We're going to systematically watch and record certain behaviors as they naturally occur. You, the researcher, you don't interfere or manipulate the environment. So this is something you see a lot in educational research. Maybe you're looking at a teacher's specific type of classroom management plan, and you're going in and counting how many times there are classroom disruptions and how frequently they employ those classroom management techniques that you're studying. So it's a real-world setting, and it's a social behavior. Cross-sectional research allows you to compare 2 different groups at a single point in time. So you're taking a cross-section, like a slice of cake. So those groups are already going to be existing there, and you're not creating them. So here's an example. It says a researcher compares stress levels between freshmen and seniors. So freshmen and seniors was already identified beforehand, and now we're just looking at differences in those groups at the same point in time to see how their stress levels differ. Now, no matter what you look at, as far as non-experimental research is concerned, there are things that you need to keep in mind. And the first thing is that it doesn't matter what design you use, a non-experimental research method has limitations. The first one is, just because I find a relationship, it doesn't imply causality. Okay? You have to keep in mind that there are always multiple possible explanations for any relationship that you find. Now, why can we not use experimental research to establish causation? Number one, I didn't have any manipulation of my independent variable. That's a requirement for causation. Two, I didn't have random assignment of my participants. That's also a requirement for causation. And three, my confounding variables are not fully controlled. And that one is a big one, because I haven't controlled for these other things out here that might be influencing the relationship. I can't say that a causal relationship exists. Now, because of these three limitations, our internal validity is going to be lower in a non-experimental research design versus experimental. So we're going to talk more about validity later on in the course. Now, you might be thinking, well, why is there a whole course here devoted to non-experimental research methods and statistics if it's not the gold standard? Well, like I said, it has its uses. First, it lets me study variables that can't be manipulated, and that is a great thing. Let's think about smoking and pregnancy. It would be very unethical for me to assign women to a smoking group and then study the outcome of the weight of the baby. That's an ethical situation that I would not be allowed to do, okay? It's often more practical to do these non-experimental measures. And as I often say in my experimental class, when I teach this experimental class, you have to have non-experimental proof of a relationship temporally, that means having to do with time, before you can explore something in a causative manner. The third reason down here is that non-experimental research reflects how it happens in the real world. So it's great for generating hypotheses, and those hypotheses can later on be tested in an experimental way, and that adds more validity and credibility to our research. So remember the limitations. Put the limitation slide in here, just kind of sum it up for you, but non-experimental research is great, but it can't establish a cause and effect relationship. It's going to be vulnerable and impacted by confounding variables. In general, there's less control over the variables that you're working with. And then at the bottom, it can be influenced by bias. And we're going to talk about that later on in depth. But bias is very much a problem when you have data that are reported by the participant. So they may downplay. Like if you were asking about cigarette smoking and pregnancy, the natural instinct of a woman who is smoking while pregnant might be to report less smoking, less packs per day, less cigarettes per day, and that's a form of bias. So, to summarize, I know this was a very quick video, but that was the whole point, was to kind of get your feet wet on what experimental and non-experimental research are, with a focus on the non-experimental. Non-experimental research is built on measuring variables and looking for relationships between them. It does have an IV and a DV, but they are conceptual. They focus on description and prediction. And the three methods that we talked about in here today were correlational, observational, and cross-sectional. And the bottom line with non-experimental research is that it only establishes an association or a relationship. It can't be used to establish causation because it lacks manipulation and control. Control would be provided by something like random assignment. Right, so I hope you enjoyed that video. There are notes for this in Canvas, and this is one of several that you're going to watch this week. So thank you for your time, and I hope you enjoyed it. Take care.